Welcome to the 2026 JEE MAIN for VAH series. Okay, in this series we are going to today we are going to observe coordinate system. Okay, so in this coordinate system, Cartesian coordinate system. No doubt, my computer screen is a Cartesian plane. Okay, if I draw one horizontal line, it gets divided into two parts. Am I right? And if I draw one vertical line and as well as one horizontal line, my total screen get divided into four parts. Each part can be called as each quadrant. You know that. So it is a two. No doubt, it is a two-dimensional space. Okay, two-dimensional plane, not space. Space means it goes to the 3D. Okay, it is a two-dimensional plane. So if you take the horizontal line, we are known that the horizontal line can be called as x-axis and vertical line is known as y-axis, and these two intersected horizon that we know, and it gets divided into four quadrants: x greater than 0, y greater than 0. You already know that. So this is x-axis and this is y-axis. Okay. So this is first quadrant and second, third, fourth. Third and fourth. Okay. So here both are positive, and here negative, positive, and negative, negative, and positive, negative. Okay. Right. So x greater than 0, y greater than 0. So both are positive in first quadrant, both are negative in third quadrant. Like that we can easily define. Okay. Now I want to represent a point. Let me take one point which is on the, okay, this is my graph. Okay. This is 1 and 2. This is 1 and 2. Okay. This is my point. Let me take. Okay. A point in the plane is represented by an ordered pair. So ordered pair you are taking. Ordered pair means which consists of two things, x comma y. So here what the x represents? It is the horizontal distance from y-axis. From this point, how much distance from y-axis, right? Not from that point. From y-axis, how much distance which is present, that can be called as x-coordinate. Okay. It can also be called as abscissa. Understand? The vertical distance from x-axis. From x-axis, if you draw the vertical line, vertical distance, it can be called as y-axis or it can be ordinate. Okay, abscissa and ordinate. These are the two important terms which are present, which are two important things which are present in a ordered pair. Or I can say x coordinate or y coordinate also we can call it as. Now like this, I am taking 2 points in the plane. Okay, A and B, 2 points. These are my 2 points. Okay, this is my Cartesian plane x and y. I want to calculate the distance between these 2 points. Say this is having the ordered pair A of x1 y1 and B of x2 y2. Then I want to calculate the distance between A and B. So this can be derived actually, but I am not deriving. I am directly moving to the formula directly. Okay. So the distance between these 2 points can be calculated in this manner: x2 minus x1 whole square plus y2 minus y1 whole square. So if you go for the special case, A and B lie on the same axis, the formula is simplified, right? If you take that these 2 points should, if the lie on the same line, the formula is going to be simplified. Okay, right. So determines the coordinates next. This is the point. We have taken 2 points, right? A and B, distance between the 2 points we found. Say I am taking one more point which is dividing the line segment in a given ratio. Say if I draw a point like this, this point divides the total line into two equal halves. 1:1, 2:2, 3:3, like that. Suppose if I draw like this, so this is more part and this is less part, right? It is going to divide it in different ratio, I can say, right? If the point which is divided internally, say this total line segment can be divided by this point in internally, okay, inside the inside the two, in between 2 points, it is going to divide. That can be called as internal division. Okay, that can be called as internal division. Suppose if it is out of the point, say like this, and it is going to divide here. This is the point which is going to divide this. Then it can be called as external division. Okay. So internal division, if you take x1 y1, x2 y2 are the 2 points. Let me take x2 y2. Okay. If it is dividing in the ratio internally m is to n, then you can write it as mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. Okay. Now, if you go for external division in the same way, for external division, you are getting negative sign. For internal division, you are getting positive sign. Both are negative. mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n. Okay. This is the, this can be called as section formula. Two different sections we are getting. Okay. This is one part, one section, other section. Like that. Okay. Very good. Let us observe the midpoint formula. Say, if the, I already told you that these are the 2 points, it is dividing exactly the middle in the equal ratio. Okay. If it is in the, exactly in the middle, then these are the coordinates x1, y1 and x2, y2. Then the midpoint, this is the midpoint. Let me take these are a and b, ab are the 2 points, and c is only the division point. I want to find the coordinates of this c. So how can I find the coordinates of c? Means x1 plus x2 by 2 plus y1 plus y2 by 2. In that manner, if you calculate, you are getting the midpoint formula. Okay, midpoint coordinates. Okay, by using this formula. Next, the slope of a line passing through AB. Say, this is the line I am taking. I want to calculate the slope of the line. Or otherwise, you take any line like this. I want to calculate the slope of this line. Okay. So, how to find the slope of the line? Say A of x1, y1, B of x2, y2 are the 2 points. Let me take. Okay. Then I want to calculate the slope. Slope is equal to y2 minus y1 by, what is that? Y2 minus y1 by x2 minus x1. Okay. And if you go for special cases, if the slope is 0, you see what is actually slope? The slope is nothing but the line which makes an angle in the anti-clockwise direction with the x-axis. That can be called as slope. Okay. Anti-clockwise direction. Anti-clockwise direction with the x-axis. That can be called as slope. Understand? So this is slope. So if it is slope is 0, means this line is going to fall onto the x-axis, or if this line coincides with the horizontal line, right? So this is going to be a x-axis, right? Horizontal line. Then the slope becomes, if for a horizontal line the slope becomes 0. Okay. If there is no slope, means because it is not making any angle in anti-clockwise direction with the x-axis, means the slope becomes 0. Okay. So the slope becomes 0 means not 0 angle it is making. Okay. Next, if you go for vertical line, I am taking. If you take for a vertical line, then what happens? You see, for a vertical line, it is going to be this, because the slope is nothing but, we know m is equal to tan theta. Hmm? Yes. Say I want to calculate the slope of slope of vertical line. Vertical line means vertical line, how much angle which is making with the anti-clockwise direction with the horizontal axis or x-axis. It is making 90 degrees. Okay, that is it is making 90 degrees, means it is going to be tan 90. Sin 90 is 1, cos 90 is 0. Okay, 1 by 0 is nothing but infinite. So vertical line is making an angle. Vertical line is making a slope of m is equal to infinite. Got it? Horizontal slope is 0. Vertical slope is infinite. Next, angle between two lines. There are two lines, suppose. I want to calculate the angle between them. So what is the angle between the two lines? The angle between the two lines whose slopes, let me take the first one slope is m1, the other slope is m2. Okay. Then I want to calculate the angle between these two lines. That is going to be tan theta is equal to mod m1 m2 minus m1 by 1 plus m1 m2. By using this formula, we can calculate the angle between the two lines. Okay. And there are special cases. If the lines are parallel, this is m1 and this is m2. You see, here the lines are intersecting. Whenever they intersect, the angle is going to form. Whenever they are parallel, is there any angle between them? No, zero angle, right? So, slopes are equal. For the parallel lines, the slopes are equal. And if you go with the perpendicular lines, these are the two lines which are perpendicular. Say the slope of this one is m1 and the slope of this two is m2. Then if you go for product of slopes, it is going to be -1. Okay. For perpendicular lines, it is going to be the product of slopes is -1. And for parallel lines, the slopes are equal. Slopes should be equal. Next, collinearity of points. Points A of x1 y1, B of x2 y2, C of x3 y3 are collinear. Collinear means the 3 points should lie on the same line. Okay, the 3 points should lie on the same line. 3 points should lie on the same line. When do you say that the 3 points should lie on the same line? That means here, if you take A to B distance plus B to C distance, the total distance becomes AC distance, then we can say that these 3 points are collinear. Otherwise, AB is here and C will be not in this line, somewhere. Okay, not this line. AB will be like this and C will be like this. Okay, it is not on the same line, like that we can say. Okay, got it? That is, if you take this is going to, because C is other point, then you can see here triangle is forming. So something triangle has some area, right? Whereas you take like this A, B and C, is there any formation of triangle? No. So the area of triangle is going to be 0. What do you say? The area of triangle is going to be 0 when 3 points are collinear. You can go like this, or in order to show the 3 points to be collinear, like ABC, AB plus BC is equal to AC. In that way also you can solve, or area of triangle is equal to 0. Anyway, you can. Area of triangle formula. Say you have a triangle means three vertices, right? A of x1, y1, B of x2, y2, C of x3, y3. Okay, right. So if you write half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. Area of triangle is 0, then the 3 points are collinear, we can say. Okay, got it? Very good. Let us observe the next locus. The locus set of all points which satisfy the some given condition. For example, locus of a point equidistant from A and B is the perpendicular bisector of the line segment AB. Locus of a point equidistant from the 2 points, say A and B, 2 points I am taking. Say if I draw the perpendicular bisector, then the perpendicular bisector of the line segment AB is nothing but, which is the locus of the point equidistant from both A and B. This distance OA is equal to OB, I can say. Okay. Then this O, uh, then O is the intersection point of these two. Then that is the perpendicular bisector of the line segment. The locus of a point equidistant from the 2 points is perpendicular bisector of the line segment. Okay, AB. Got it? Yes. Next, polar coordinates. Points can also be represented using, we know points be represented in the form of x and y. X coordinate, y coordinate. X coordinate can be called as abscissa and y coordinate can be called as ordinate. Okay. In the same manner, you can express these in polar coordinates r comma theta. Okay. What is r and what is theta? We will observe. Distance from the horizon is called the r. Okay. And angle between the angle with the positive axis can be called as angle with the positive x-axis is called theta. Okay. So x is equal to r cos theta, y is equal to r sin theta. We can express. R is equal to square root of x square plus y square. Okay. And tan theta is equal to sin theta by cos theta is equal to y by x. Okay. In that way, you can write. Understand? So this is the polar form in terms of r comma theta is the ordered pair. Okay. Next, transformation of axis. If you see the transformation of axis, the very first one is translation of axis. Suppose I am taking O dash of h comma k. Okay. If O dash h comma k, the transformation x dash is equal to x minus h, y dash is equal to y minus k. That means it is going to shift some h units from horizon, from x, from x comma y, from x comma y is the original point. It is going to shift h comma k units. Okay, h comma k units. Then the transformation of coordinates are x is equal to x dash x dash becomes x minus h, y dash becomes y minus k. Okay. If the axes are rotated through an angle theta, here they moved certain distance. That is called translation. If the rotation of axis, if the axes are rotated through an angle theta, it can be called as x dash is equal to x cos theta plus y sin theta, and y dash is equal to minus x sin theta plus y cos theta. So this is the rotation and this is the translation. Translation means just shifting the points from just depending upon the order pair. Okay, they are shifting the axis, whereas rotation of axis is different. Rotation of axis means it is changing its angle. I can say in terms of angle. If you say rotation of axis in terms of distance, it can be translation of axis. Got it? Translation and rotation of axis. Next, equations of geometric shapes. You see, here y is equal to mx plus c. Y is equal to mx plus c is a line which is not passing through horizon. Whenever any line which passes through the horizon, it is going to be y is equal to mx, which is not passing through horizon. Y is equal to mx plus c, something like that we can say. Okay, if it not does not passing through horizon, y is equal to mx plus c. So if you go for a circle equation, x minus h whole square plus y minus k whole square is equal to r square. Okay, this is the equation of a circle. If you take the ellipse equation, x square by s square plus y square by b square is equal to 1. And for parallel parabola, y square is equal to 4ax. And for hyperbola, x square by a square minus y square by b square is equal to 1. In this way, we can write the geometric shapes. Okay. And their equations. Got it? Next is symmetry. This is very important with respect to symmetry with respect to what? That is important. About x-axis. So symmetry about x-axis, if you want to say about x-axis, you replace y with minus y. Y can be replaced by minus 1. If you want to replace, about y-axis, I want to make a symmetry. That means x can be replaced by minus x. Okay. Absolute origin. Replace x with minus x and y with minus y. This can be called as absolute the origin. Absolute the origin. Got it? Absolute the origin means x can be replaced with minus x, y can be replaced with negative y. Next, transformation of axis. Transformation of axis refers to the process of changing the coordinate system, neither by shifting the horizon, neither by shifting the horizon or rotating the axis. Okay, that means you are changing the either distance or angle. Okay, these transformations help simplify problems or analyze the equations more effectively. There are two primary types of transformations. What are the two primary types? Already we observed translation of axis. The new axis have the horizon coordinates x, k, old axis. X, k are the coordinates of the point of the old. And this is going to be the new. X is equal to x dash h plus y is equal to y dash k. Okay. And x dash is equal to x minus x h dash, y dash is equal to y minus k. Okay. Right. Next, effect on equations. For a curve with equation f of x comma y is equal to 0, the original system, the equation in the system is given by. Yes, this is going to be fx dash plus h comma y dash plus k. So this is equal to 0. This can be effect of equation. Therefore, at the beginning, f of x comma y is equal to 0. Okay, f of what I say? F of y x comma y is equal to 0. Next, if you go for rotation of axis, this occurs when the coordinate axes are rotated counterclockwise direction through an angle theta, anti-clockwise direction through an angle theta about the horizon. Okay, without shifting the horizon here. Here there is no shifting of horizon. Previous case we are shifting the horizon. Okay, transformation equations. If x comma y are the coordinates of a point in the world system, x dash y dash are the coordinates in that rotated axis. X is equal to x dash cos theta minus y dash sin theta. Y is equal to y dash cos sin theta plus y dash x dash sin theta plus y dash cos theta. In that way, you can easily write. Or equivalently, x dash is equal to x cos theta plus y sin theta. Y dash is equal to minus x sin theta plus y cos theta. Okay. And the effect of equation. For a curve, f of x comma y is equal to 0 is the equation of the rotated system of the. Then it becomes f of x dash cos theta minus y dash sin theta, x dash sin theta plus y dash cos theta. Got it? Next, combined transformation. In many cases, are both translated and rotated. The transformations are applied sequentially. The transformations we are applying sequentially. Okay, right. So that you observe the translate the horizon to h comma, rotate the angle by theta, combine the translation equation. So how it is going to be? First translation. First translate, then rotate. Okay. So if you translate, you are getting x dash is equal to x minus h, y dash is equal to y minus k. And then if you go for rotation, it's going to be x double dash is equal to x cos theta, x dash cos theta, not x cos theta, minus y dash sin theta, y double dash is equal to x dash sin theta plus y dash cos theta. Okay. In this way, you can easily understand. Next, the nature of quadrilateral. What is the nature of quadrilateral? Quadrilateral can be determined using distance properties and derived from the coordinates of quadrilateral. Okay. By using different vertices, you can say the nature of the quadrilateral. Okay. So distance formula you already know. Okay. Distance formula. And if you go for general quadrilateral, the quadrilateral has no doubt four vertices, four sides, two diagonals, and four angles. Okay. These are the main important things which are present in our general quadrilateral. Next, types of quadrilateral and their properties. So let me take parallelogram. What is a parallelogram? A parallelogram is a figure in which opposite sides are equal. This side is equal to this side. This side is equal to this. Okay. Parallelogram. These are called diagonal. Okay. That means opposite sides are equal. AB is equal to CD. This is equal to DA. And diagonals, if you go for diagonals, bisect each other. Diagonals are going to bisect each other. Midpoint of AC is equal to midpoint of AD. Midpoint of BD. Okay. And if you write the midpoint of AC, x1 plus x3 by 2, y1 plus y3 by 2, or x2 plus x1 by 2, y2 plus y4, x2 plus x4 by 2, y2 plus y4 by 2. In this manner, we can easily write x1 by x1 y1, x2 by 2, x3 by 3, x3, x4 by 4 are the coordinates of the four vertices of the quadrilateral. Got it? Okay. Next, you see types of quadrilaterals. That is, we observe the parallelogram. Okay, we observe the parallelogram, and very next one is rectangle. All properties of a parallelogram which satisfied by this rectangle, and diagonals are also equal, and each angle is 90 degrees. Okay, each angle is 90 degrees, and each angle is 90 degrees and diagonals are equal, then that quadrilateral is going to be a rectangle. Okay, very good. Next, rectangle. If you observe the rectangle properties, all properties of parallelogram, diagonals are equal. Okay, and then AC equal to BD, I can say. Two diagonals. Each angle is 90 degrees, which can be verified by which can be verified by checking perpendicularity. Okay, that is slope of AB is to slope of BC is equal to -1. Slope of AB is to slope of BC, which is equal to -1. And next you go for rhombus. All properties of the parallelogram are going to satisfy. All sides are equal. Rhombus is a parallelogram, no doubt, and all sides are equal. That is AB is equal to BC equal to CD equal to BC equal to CD equal to DA. Okay, all sides are equal, and also diagonals. Okay. Diagonals, all properties of parallelogram, all sides are equal. AB is equal to BC, which is equal to CD equal to DA. Diagonals bisect each other at right angles. AC and BD intersect at 90 degrees. So slope of AC into slope of BD is -1. Why? Product of slopes is -1, then the angle between them is 90 degrees. Next, if you go for square, all properties of a rectangle and rhombus covered in this rectangle and rhombus. All sides are equal, diagonals are equal and perpendicular. Okay, this is the other thing which is going to add here. Next, trapezium. Only one pair of sides are equal. Only one pair of sides are equal and parallel. Okay, one side of in this. Slopes of parallel sides are equal. Slopes of parallel sides are equal. In trapezium, slope of AB is equal to slope of CD. Okay. Slope of AB is equal to slope of CD. Slopes of parallel sides are equal. That is very important in case of trapezium. Next, if you go for kite, two adjacent sides of sides are equal. That is AB is equal to BC, CD is equal to D. Sides of adjacent sides are equal. Diagonals are perpendicular. Kite. In kite, diagonals also perpendicular. Got it? Diagonals perpendicular. Next, tips to determine the nature of a quadrilateral. Suppose they give one figure. If you want to find the nature of the quadrilateral, so calculate all lengths. Use the distance formula AB, BC, CD, and DA. Okay, and check the diagonals and verify the slopes to check parallelism or perpendicular upsides or diagonals. And opposite sides are equal. It's a parallelogram. Opposite sides are equal. Diagonals are equal. Then it is going to be a rectangle. Okay. Next, only one pair of sides are parallel. It is going to be a trapezium. Next, so this is the steps to calculate the nature of the opposite sides are equal, then parallelogram. Okay, opposite sides are equal and diagonals also equal. Diagonals also equal, it is a rectangle. All sides are equal, rhombus or square. Only one pair of sides are parallel, it is a trapezium. Understand? Next, you see, like that is, these are the yes. So these are the opposite sides are equal. It's a parallelogram. Opposite sides are equal and diagonals also equal. Then it is a rectangle. All sides are equal. Rhombus. Only one pair of sides are equal. It is a trapezium. The area of triangle in a coordinate system can be determined using the coordinates, vertices, or geometric properties below. So you have different various methods in order to calculate the area of rectangle. That is shoelace formula: x1 y1 x2 y2 x3 y3. You can write in the form of like this. You can write this in the form like this. You can write in this manner. Let us observe. Sorry. Come on, let us look at this. So we can write this area of a triangle. If you want to calculate ABC x1 y1 x2 y2 x3 y3. Okay. These are the 3 points. In order to calculate the area of these three, you can write it as x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So substitute the coordinates of the vertices into the formula and you are going to simplify it. X1 into, so you can easily remember in this manner. X1, okay, X1, 1, 2, 3 you have to get, okay. And here also again 1, 2, 3. 1, 2, 3, no? 1, 2, 3. 2, 3, 1. Next, 2, 3, 1. Next to 3, 1, 2. Like that. You see, 3, 1, 2. 2, 3, 1. Cycle. 1, 2, 3. 1, 2, 3. First one. 2, 3, 1. Next, 2, 3, 1. After that, 3, 1 and 2. Okay. Cyclic manner. You can easily remember this. Area is equal to half into x1 into y2 minus y3 plus x2 into y2 y3 minus y1 plus x3 into y1 minus y2. Substitute the coordinates into the formula. Take the absolute value and divide it by 2. You can get the answer. Okay, in this way we are going to calculate the area of triangle by using base and height. You know, half into base into height, area of triangle. Using the determinants, you can calculate x1 y1 1, x2 y2 1 and x3 y3 1. You can calculate the determinant value. Next, one of the important points which are present in the what do you say, centers which are present in the triangle. Okay, what are the different centers which are present in the triangle? Centers of a triangle. If you go for centroid, that is the first center. Say this is of a triangle ABC. The centroid is the point where the medians of a triangle intersect. Say median. What is a median? Median is the, say these are the three medians A, D, B, E and C, F. Let us take. So what is a median? Median means a line segment joining from vertex to the opposite side midpoint. Vertex to the opposite side midpoint. If you join it, Whatever the line you are getting, that can be called as median. So AD, BE, and CF for the medians. These three are meeting at one point. So it can be called as point of concurrence. Okay. So point of concurrence of medians can be called as centroid. What is centroid? Point of concurrence of medians is called a centroid. Very good. And median is a line segment joining the vertex of a triangle to the midpoint of the opposite side. Okay. Properties. The centroid divides. So this is our centroid. It is denoted with the letter G. Okay. It divides each median in the ratio 2:1. Okay. It divides each median in the ratio 2:1 with the longer part being closer to longer part being closer to the vertex. Longer part is being closer to the vertex. Okay, like this. 2:1. 2:1, like that. If the vertices of a triangle A1, X1, B1, B of X2 by 2, C, X3 by 3, coordinates of the centroid. If you want to calculate the coordinates of centroid, if it is X1 by 1, X2 by 2, and X3 by 3, just by adding all the 3 and divided by 3, you are getting the X and Y coordinates respectively. X1 plus X2 plus X3 by 3 by 1 plus Y2 plus Y3 by 3. In this manner, you can easily calculate the value of centroid. Okay. Centroid coordinates. Next, circumcenter. What is the circumcenter? If you draw that, these are all centers we are observing. No? Say this is again a triangle A of X1 by 1, B of X2 by 2, C of X3 by 3. Okay. Centroid is the perpendicular bisectors of the side. Suppose I have drawn a perpendicular bisector from this point. For this side also, if I draw a perpendicular bisector below this side. Next side, for this side, I am going to draw the perpendicular bisector. No, sorry, wait. Perpendicular bisector means you have to take more than half and you have to draw it, right? This way. And for this also you are getting like this. And for this also you are getting these perpendicular bisectors. These two are meeting at a point. Okay, meeting at a point. O that can be called as circumcenter. What is that called? Circumcenter. Perpendicular bisectors meeting at a point is called circumcenter, and this perpendicular to the side of the triangle and passing through its midpoint. A perpendicular bisector is a line with the perpendicular side passing through the midpoint. You know that. Okay, perpendicular bisector definition they give. And if you see the properties, the circumcenter is equidistant from all the three vertices of the triangle. The circumcenter is equidistant from all three vertices. From here to here, this length is equal to this length, thick length. These three are equal. It is equidistant from the vertices. Okay, got it? Very good. Next, acute angle triangle. If you take it, it is going to be inside the triangle. And for a right angle triangle, it is going to be midpoint of the hypotenuse. Like here, you are getting the circumcenter. Okay. Next, location. For acute angle lies inside the triangle. For right angle lies in the midpoint of hypotenuse. Why? Because hypotenuse is the diameter of the circle. This is going to be diameter. Like this, you will get. Obtuse angle triangle lie outside the triangle. Okay, outside the triangle, closer to the obtuse. Okay, got it. Next, incenter. The incenter is the point where the three angle bisectors of a triangle intersect. Three angular bisector. This is my triangle. If I draw the angular bisectors like this, three angular bisectors which are meeting at a point, the intersection center of the circle inscribed within the triangle. Okay. A angle bisector is a line that divides the total angle into two equal angles. Okay. Two equal angles or two parts. The incenter is equidistant from all the three sides of the triangle. This is incenter, equidistant from sides. It is not equidistant from vertices. Vertices is circumcenter and equidistance from sides is incenter. Got it? Next, if you go for the formula in the same manner, ABC are the lengths of the sides of the points. Okay, sides of the then what you are getting in center? I is equal to ax1 plus bx2 plus ax3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. Location of all triangles always lies inside the triangle, irrespective of the type of the triangle. Okay. Next, orthocenter. The orthocenter is the point where the three altitudes of the triangle are correct. Okay. Acute triangle inside the triangle, right triangle at vertex of the right triangle, obtuse angle triangle outside the triangle. Okay. Uh, so this is orthocenter is the point altitudes of all triangles. If you observe this centroid, it is in all inside and the right angle inside, and midpoint of hypotenuse is inside all the right angle vertex inside, outside, and the inside and outside. Okay, like this we can observe all the different things. Okay, the triangle, right angle triangle, and